Good afternoon. I am Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering at Akgec, Ghaziabad. Today I am going to discuss a very important topic, that is feedback amplifier. I think all of you are familiar with the concept of amplifier. Actually, amplifier is a device which increases the signal strength. For example, if you have any signal whose strength is, or I should say that amplitude is somewhat smaller, and if you want to increase its strength, then you can pass it through amplifier so that its amplitude will increase. However, the frequency will remain same, and amplifiers are one of the most used device in electronics. And all of you know that for amplification purpose we use transistors, that may be BJT or FET, anyone you can use. And feedback is the concept in which we take output or we will take some part of output and then again feedback to the input. For example, if we have this amplifier A, if it is input and here is the output, if we will take some part, you will take output and some part and then you will apply towards the input, then this type of system is known as feedback amplifier. So, if a feedback system is one in which the output signal is sampled and then fed back to the input to form an error signal that drives the system. Okay, so feedback systems are useful and they are generally used in oscillators, process control systems as well as other electronic systems. Actually, if you will concentrate on this diagram, or even I can show one more diagram, this is actually this is good picture where we can discuss the concept of feedback. You can see here that we are taking output and then we are applying it to the input. If this is the signal and this is the feedback signal, if they are subtracting from each other, that means if xi means this signal is the difference of xs and xf, then this type of system is called as negative feedback system. Obviously, there can be the two ways in which we can mix this signal. One is the negative feedback and another case may be when this sign will be the positive sign. In that case, it is for negative feedback. And for the positive feedback systems, xi will be equal to xs plus xf. And there are only two possibilities. There is no more, there is no other possibility where you can mix these two signals in another way. And the two ways are, one is when you will add xs and xf, another is when you will subtract xf from xs. So, one is the negative feedback system, another one is the positive feedback system, and this is the diagram of actually negative feedback system. So, let us discuss few more things related to feedback amplifier. So, whenever we will do analysis, its analysis will be simple for us. This x naught means output. This is the amplifier, this is simple amplifier whose gain is A. So, x naught will be equal to A into xi. Xi is this input signal. This is the feedback circuit. This is the feedback circuit in which one symbol is there, that is beta, which is known as feedback factor. So, what will be the feedback factor? Feedback factor beta is equal to its output is xf and input is x naught. So, beta is equal to xf upon x naught, or in other words we can say that xf is equal to beta into x naught. So, feedback network will take output and it will reduce this signal and it will provide its part to the input for the mixing purpose. And obviously, A is much greater than 1, where A is the gain of amplifier or open loop gain, and beta is the feedback factor and its value will always be less than 1. And we all know that A is equal to A means gain of single or simple or open loop amplifier, its gain will be equal to x naught upon xi, which we have discussed earlier. And AF, let us go to the previous diagram. Its output is x naught and its actual input is xs. So, AF, that means gain with feedback. Gain with feedback is equal to x naught upon xs. And we know that xi is equal to xs plus xf. So, actually we will write xs. So, xs will be equal to xi plus xf. Now, let us put this equation with this. So, you will get AF is equal to x naught upon xi plus x. Let us divide numerator and denominator by xi. So, what we will get? We will get x naught upon xi, it will be 1 plus xf upon xi. So, x naught upon xi is A upon 1 plus this xf, and here is xi. So, I can divide xf by x naught and here I can multiply with x naught. So, you will get the sum factor, that is xf upon xi. So, reduce this expression, I have rearranged this expression like this, and in this case xf upon x naught we have discussed earlier, xf upon x naught is beta and x naught upon xi is A. So, it will be A upon 1 plus beta A, or in the simplest form I can write it like this, that AF is equal to A upon 1 plus A beta. So, this is the overall gain of feedback amplifier. And one more thing, if you will observe this expression, simple gain is A, that means gain without feedback is A, and gain with feedback, I am talking about negative feedback. I have earlier told you that this time I am going to discuss negative feedback. In next lecture, we will discuss about positive feedback, but this time we will discuss negative feedback only. Positive feedback have a specific use, that use is oscillator. That means whenever we need oscillator, we will use positive feedback. So, if we will concentrate here, gain without feedback is A and gain with feedback is A upon 1 plus A beta. That means in this case gain has been decreased. So the name arises negative feedback. Actually, negative feedback name is given due to this negative sign. And from negative, you can remember that in case of negative feedback, gain with feedback decreases, as you can see here. So you obviously you may have one question that our purpose is to amplify the signal, and this negative feedback system is reducing the gain. So what is the importance of using negative feedback, or why we are moving towards negative feedback system from simple amplifier, even though the gain decreases in case of negative feedback? Obviously, there must be some advantages. That's why we are moving towards negative feedback system. What are those advantages that we will discuss very soon? And if we will see here, AF is equal to A upon 1 plus A beta, and generally A beta is much greater than 1. So you can write AF is equal to A upon A beta nearly equal. So it will be equal to 1 upon beta. It is very surprising result that gain with feedback is nearly equal to 1 upon beta. What does it mean? It simply means that the gain, a dependency of gain now is on the feedback network only. And in case of simple amplifier, as we have seen, in case of BJT and MOSFET, that gain of the simple amplifier, that means BJT and FET, depends on various parameters. That means it depends on temperature, it depends on several other parameters. But in case of feedback system, negative feedback system, you can design feedback network in such a way so that its gain will not vary with various parameters. This is one advantage. These are few more advantages, like it desensitizes the gain. That means it makes the value of gain less sensitive to the variation in the value of circuit component, such as might be caused by change in temperature. That means various components value can be changed with respect to temperature, so it will desensitize the gain. Second is reduce the nonlinear distortion. This is another advantage. One more advantage, reduce the effect of noise, control the input and output impedances. Actually, you can achieve the required resistance either input or output. Very soon we will see this, that how we can control the input and output resistance. Another advantage is extend the bandwidth of amplifier. This is also one significant advantage of negative feedback. And you can remember it very easily that gain and bandwidth product is constant for any amplifier, and we have seen earlier that gain decreases in case of negative feedback. So whenever gain will decrease, obviously bandwidth will increase. So negative feedback have several advantages. There is only one disadvantage, that is gain decreases in case of negative feedback. So you cannot simply think that why we use negative feedback amplifiers even though the gain decrease. Yes, it's true that gain decreases, but it provides several other advantages which are mentioned over here. So you need to remember these advantages also. You cannot concentrate on gain only. Actually, feedback amplifiers are categorized into 4 types: voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So before the discussion, I should say that you can easily remember their names if you have. Obviously, if you will listen these names first time, then you have difficulty in remembering these names. So, in simplest way, you can remember it as I am giving another name. That means I am not, this time I am not giving you the direct names. First of all, I am categorizing the feedback amplifiers into 4 types, that is voltage feedback amplifier, current feedback amplifier, conductance amplifier, resistance amplifier, it is actually we are familiar with voltage, current, resistance and conductance, so it is very easy to remember these 4 names, and soon we will derive these 4 names from these 4 names. Actually, I will consider these circuits one by one. Actually, it can be easily seen that in this case, output is voltage, input is also voltage. So, it is voltage amplifier. And remember 2 things. Concentrate on this diagram only. In this case, what is happening? 2 things are happening. One is sampling, that means how you are taking output. Another is mixing, that means how you are mixing this Vs and Vf. So, you need to remember 2 concepts, one is sampling, another one is mixing. Okay. So, in case of voltage, sampling is done in parallel or shunt and mixing is done in series. Okay. Is it clear? Sampling is done for voltage, sampling is done in shunt, mixing is done in series. For current, let us consider this example of current. For current, sampling is done in parallel and mixing is done in series. Oh, sorry. Sampling is done in series and mixing is done in, you can see it is shunt. So, now let us derive these names. This is voltage amplifier. At the output terminal or towards output, there is voltage and sampling is done in series. So, it have name voltage series feedback. voltage series feedback. I think now it should be clear. Let us consider this. In this case, towards output, which quantity we have? We have current, and its mixing is done in shunt. So its name is current shunt feedback. I think it is conceptually related, or now you can remember it very easily that how we can call voltage amplifier as voltage series feedback amplifier and current amplifier as current shunt feedback amplifier. In this case, you can see this is output is voltage and towards input there is current. So it is V upon I is what? V upon I is resistance. So you can remember it as a trans resistance amplifier. So in this case, output is what? Voltage, and its mixing is done in shunt. So it is voltage shunt feedback. In this case, you can see towards output is current I naught. So and mixing is done in series. So its name should be what? Its name should be current series feedback. So its name is current series feedback. So their naming is clear. Even there is one more name, that is towards input connection is in, mixing is in series, sampling is in shunt. So its third name is series shunt feedback, shunt feedback, series feedback, shunt series feedback. And earlier I told you that we can control the input and output resistances of the amplifier with the help of feedback. Control means we can increase or decrease the input and output resistance. How? See. There is one factor, that is 1 plus A beta. You need to remember this factor. If at the input side series connection is there, then input resistance will increase by a factor 1 plus A beta. For example, in this case, RIF should be equal to RI into 1 plus A beta. At the output side, ROF, that means feedback resistance or resistance with feedback, output resistance with feedback will be R naught upon 1 plus A beta. That means if shunt connection is there, you should divide the resistance by 1 plus A beta. If series connection is there, then you should multiply by 1 plus A beta. In this case, you can choose any. Let us choose this. In this case, output resistance will be ROF will be equal to RO into 1 plus A beta. RIF, in this case, RI into 1 plus A beta. RIF is RI upon 1 plus A beta. ROF is RO into 1 plus A beta. RIF, RI upon 1 plus A beta. ROF, RO upon 1 plus A beta, because these two connections are in shunt. So this is the concept which you can remember to solve any kind of numerical. Whenever you will have the value of A, you will have a value of beta, and you have a value of input and output resistance with feedback, and then you can easily find out the value of resistances with feedback. So this is what which we have to discuss today. Thank you.